This screencast will teach you how to utilize the rigorous heat exchanger method in Aspen Plus software. To begin, open your shortcut heat exchanger method and purge the results by clicking on the backwards blue arrow at the top of the screen. On the menu tree, click on Setup under the HeatX block. Change the calculation type from design to rating and the model fidelity as shell and tube. A dialog box will appear asking if you would like to convert to a rigorous exchanger. Click Convert and then click OK. Change the calculation mode again to rating. For this simulation, specify the tube outer diameter as 0.025 meters, the shell inner diameter as 1 meter, the tube length as 3 meters, the baffle spacing as 0.25 meters, the number of baffles as 5, and the number of tubes per pass as 300. Click on Size and then Accept Design. Run the simulation and click on Thermal Results in the menu tree. Notice how the actual exchanger area is only slightly larger than the required exchanger area. This means that the heat exchanger is only slightly over-designed by about 0.45%. Furthermore, Aspen also provides a UA value for the heat exchanger. Click on Summary to view the inlet and outlet temperatures and pressures of each stream as well as the heat duty for the exchanger. We will now create heating and cooling curves to learn more about the exchanger. To make a heat curve for the hot side of the exchanger, click on Hot H Curve on the menu tree. Click New and then OK. Leave the independent variable as the heat duty and the number of data points as 10. Run the simulation and then go back to the Hot H curve. On the Results tab, you can look at the data in tabulated form or you can create a plot. Click Custom and leave the x-axis as point number and select the variables you want displayed on the y-axis. For this screencast, we will select heat duty, vapor fraction, and temperature. Click OK to generate the graph. From this, we can see how the heat duty, temperature, and vapor fraction change through the hot side of the exchanger. Next, we will create a heat curve for the cold side of the exchanger. On the menu tree, click on Cold H Curves. Click New, and again leave the independent variable as the heat duty and the number of data points as 10. Run the simulation and view the results. Once again, create a plot of heat duty, temperature, and vapor fraction versus the point number. Note how the heat duty, temperature, and vapor fraction change through the cold side of the exchanger. Watch the following video in the YouTube playlist to learn how to use two heater models to model a heat exchanger. For more Aspen Plus tutorials, visit the Lafayette CHBE YouTube channel.